Good afternoon. My name is Randy Armstrong. I'm the chair of the OPC UA Security Working Group, and I would like to talk to you about RESTful APIs for OPC UA. RESTful APIs are APIs that conform to the REST architectural principles. These principles are statelessness, meaning each request is self-contained and does not require the server to maintain knowledge of previous requests. Uh, Generally, when you're using OPC UA, we have a concept of a session, which is used to store some information about the client, including authentication, locales. One of the things that we will need to address when it comes to developing RESTful APIs for OPC UA servers is addressing the requirement for statelessness. Client-server architecture, this maps nicely onto the way OPC UA is already designed. We already have a clear division of capabilities between the server or backend and the client or front end. Uniform interface refers to having a consistent design pattern, so your way you access different resources is exactly the same, or at least follows the same design patterns. And of course, this is something that we've been doing in UA all along. Cacheability. This is limited use in industrial applications, although there's some cases where it might make sense, but it's certainly not something that is prevented from happening by the OPC UA architectures. People could come up with applications where they do cache responses, maintain cached responses to generic requests, um, but that's not the typical use case. And the last architectural principle is the principle of decoupling, where the client does not rely on having a direct connection to the server. There could be any number of intermediaries in between, such as firewalls or proxies, that do additional processing as required. Um, with some transports in OPC UA, this is already something that you can take advantage of, and I'll be talking a bit about that in some of the future slides. So one of the questions that comes up is, well, why do we care about RESTful APIs for UA? And as adoption of UA is started to take off, we've had a lot of IT programmers express interest in being able to get access to OPC UA data. And these web programmers are used to using simple HTTP-based APIs to access this data. And when we tell them that, well, yes, you need to create a TCP socket, you need to use our binary protocol, that creates can create learning curves that make it more of a challenge to take advantage of OPC UA especially in a cloud environment. And there are also numerous tools that exist to facilitate development with these REST-based APIs. And we want to be able to take advantage of those tools, obviously, so more people can develop OPC UA applications and take advantage of the and be able to access the factory data easily. So it's important to remember that RESTful APIs have been around in UA for a long time. The HTTPS transport has been supported for years. You've always been able to take any of the existing OPC UA services and post binary XML or JSON messages to a web endpoint and then get a response. And you can do all of your interactions with the UA server via this REST-like interface. This also, as soon as you start using HTTPS, you now have a mechanism that supports the decoupling, which is an important part of the REST architectural principles, such as getting through firewalls and proxies. However, traditional OPC UA services have sessions. And these sessions are important, especially when it comes to maintaining your subscriptions, and in particular, the change-based, the report on change mechanism, which is kind of core to how UA works, requires that the server keep track of what it had previously sent to the client. And that's a big chunk of state information that has to be maintained. But not everything that a UA server does has to be done with a session. And so we introduced in version 1.04 the ability to invoke sessionless services. In this case, the authentication is done on each call, on each request, by passing a user token in the header. Um, it's important to remember that these sessionless services are only supported on a finite number of methods, which we explicitly state: browse, translate, read, write. All of these ones where it's fairly obvious that the semantics do not require a session. And there's a link there to the appropriate reference in the specification describing how sessionless services work. Now, so we've had RESTful APIs in UA since 1.04, and anybody's been able to use them, but a lot of people didn't realize they were there. And or if they were there, they weren't quite sure how they could take advantage of them. And that's where the work we're doing now becomes important. Because when you're developing RESTful APIs today, it's important to have a definition of your APIs using the languages that people are expecting you to use, in particular OpenAPI 3.0. And so what we are doing now is we are creating an OpenAPI definition of all of the sessionless services, and we'll be making those available publicly. Now, in keeping with the need to keep everything stateless, there'll be no webhooks, no subscriptions. It would just be for read, write, call, those kinds of services, and browse. One thing we are going to do with the RESTful services is we want to make sure that everybody who's implementing this stuff supports modern authentication methods, in particular a centralized identity server, which you can access via a protocol like OAuth 2. We will also be working on tooling to ensure that we can take our existing definitions of types and convert them automatically to OpenAPI compatible schema definitions, because we don't want to be redoing the effort. It doesn't really make a difference semantically and structurally. All the information is captured in the XML-based node sets, and there's no reason that can't be converted automatically to a JSON schema document, which we will take care of and make the tooling available. Now, one enhancement we are adding to the specification as part of this effort has been a long-standing request to have self-contained node IDs. Now, to provide a bit of a context, an important feature in OPC UA is the ability to integrate many diverse information models into a single server and have them all coexist seamlessly. Now, this requires that every identifier and every name be qualified by an identifier for the model, which we call a namespace URI. And these URIs are typically long strings. To optimize messages, we have required that the messages use indexes that refer to a table of URIs that is maintained within the context of the session. And while this works really well for the binary protocols and any sort of sessionless or session-based communication, it creates some issues for RESTful API design. And so we've said, okay, for when we're using RESTful, you can use self-contained strings. You take the hit with the larger messages, but you no longer need that URI table maintained somewhere. We are also limiting the definition for our RESTful APIs to post, and we're not going to be using any query parameters. And this allows us to reuse the existing code and be consistent with what we've already have in the specification, and also eliminates the need to tie our definition of our API to HTTP specifically. So while 99% of people out there will likely want to use HTTP to implement this communication, it will be possible to use with other transports such as MQTT or Kafka or any other kind of IT infrastructure where you just need to be able to send a message and eventually get a response back. And so that, for all those reasons, it seems logical to limit our design to post. So to give you a better flavor of what you're going to end up dealing with when you start using the RESTful APIs. So I've taken a read request and I've got an example of what a read request would look like on the right. Now at the top you'll see that there is this table of namespace URIs, and we didn't want to throw away the namespace URI tables because it is an important optimization that is going to be needed in some cases, but it's optional. And in this case, the table only contains strings that are actually referenced in the request. So the request itself is completely self-contained. So if you have an index of 2, that refers to the second entry in the namespace URI table. Of course, it's up to the sender to decide whether or not they want to use the table for every API, every node ID, or only some of them, or it could simply not use them at all and simply use full URIs in every node ID that it provides. Now the rest of the parameters, this is an important principle, is they're going to be identical to the services that are already defined and most importantly already documented with a link to the read request definition on the web there. So this is to leverage all of the existing knowledge as well as the existing documentation to make it a lot easier for people to understand what they need to do in order to get the APIs in order to build applications that communicate with UA servers. So here's the read response where you have the namespace table at the top, which refers to URIs which are referenced in the response, and it has absolutely no connection with the table that's used in the request. In this case, the sender is the server, and it's up to the server to just make the decisions on whether to use self-contained node IDs or indexes, and the receiver always has to be able to handle both possibilities. The other thing about the responses is there's a service result in the body of the message. The RESTful API that we'll be developing will not use HTTP codes for application level errors. These will all be communicated via the service result in the response messages. This is partially to keep our response messages independent of the HTTP protocol, and also because the service results allow us to have richer error text information than you would get with a HTTP code, or more specific errors. Now, one of the values of OPC UA is the ability to take many different information models from different sources and integrate them into a single server and have them all coexist nicely. Now, what this means is that you can get back data types which from a server that were not known when the server was originally developed. They were potentially dynamic. They were loaded based on configuration. and the client is not going to necessarily know what these were in advance. And it's important that the API that we're defining will allows for this flexibility, but more importantly, provides the information you need to get the syntax and the semantic information you need to understand the types that come back. And so specifically what we have here is this type ID that will show up. And this type ID includes a namespace URI that identifies the model that defines the type and the identifier for that type. And what this means is that you can take that model and you could look it up. Either have the client can have a local cache of models that it already knows about, or it can take the URI and go get it from a service like the UA Cloud Library to download the node set. Or once we get all of our tooling in place, you could actually use a method that will be on the cloud library to get the JSON schema definition. So what we have here, and this is going to be part of this overall vision, is to be able to continue this process of seamlessly integrating all this data from all these different sources and being able to leverage all the infrastructure that we're already building to support your typical UA servers, and basically making it easy for client developers to be able to access the semantic information that they're going to need to have in order to properly process the data that they're getting back from the server. And obviously, the reverse process also allows clients to get information that they can use to send information to the server, which in the format or the structures that the server expects. Now, one trend which we have seen a lot of applications, a lot of out there make good use of, and that is the use of structured query languages that allow the client to reduce the number of network calls by specifying exactly what they want. So practically what this means is without a structured query language, if you wanted to populate a display, you typically would have to do uh, might have to do something like you have to do a browse again, and then a read, maybe another read. And so multiple calls to collect all the data that you need, and then you need to store this information in some sort of local cache. The structured query languages eliminate the need to do this, because what they do is you build up exactly what response you want to get, and it's up to the server to get all the information that you need and return it as a single packet. Now, this moves the processing complexity for a request from the client to the server. This enables thin clients, but puts a much bigger burden on the server. So it's not something that's going to be universally applicable, especially if you're dealing with UA servers running on small devices. But it will be a tool that will be very useful for cloud-based UA servers, or any sort of aggregating servers that are running on more on beefier hardware, and and it's definitely something that's going to be part of the toolkits that we want to, or the suite of features that we want to have there. Now, it's worth just sort of put a caveat in here. We haven't decided on which query language we're going to use. People have had a lot of success with GraphQL, but there are advantages and disadvantages to other things such as GQL, OData, and we'll be looking at these different options and try to pick one for a primary option while allowing the flexibility for individual applications to use a different one. But I'm excited about this particular feature because I think it really has the potential to take UA client development to the next level. Now, just to give you an update of the current status, the API, basically the Swagger mapping, is the first stage, and we hope to get that out sometime this year. The GraphQL mapping will probably be 2024. Anyone who's an OPC Foundation corporate and end user member may participate by joining the UA working group, and you can either look at the material and the prototypes that we're developing, or you can actively participate in the bi-weekly meetings. Now, that said, all the capabilities, and I really, really want to emphasize this, all the capabilities that you need to implement a RESTful API in a UA applications are already in the specification as of 1.04 with the sessionless service calls. So, and what we're going to eventually end up is going to be something that's going to look a lot like, is going to look a lot like the sessionless service calls with some enhancements. So if you want to move forward with RESTful API development, you can do it today. That completes my discussion for today. I hope you found the topic interesting, and I thank you for taking the time to listen. The webinars will give you an opportunity to post questions, and we'll get responses to you either immediately or they'll be posted later. If you have any further follow-up questions, you're welcome to post them to the OPC Foundation forum, and I'll be happy to answer them. And if you are an OPC Foundation member, I encourage you to join the working group so you can evaluate the prototypes and provide some of your requirements and your thoughts in terms of what you would like to see to make it most useful to you for your applications. Thank you very much and have a good day.